Welcome back to Everything EOS, the longest running EOS podcast, going back to March 2018. This is episode 130, and I'm here with two of the biggest legends within EOSIO. We are recording this on June 14th, and exactly 2 years ago was the day that the EOS mainnet was unlocked. I guess we'll start this off with a little bit of a toast and a cheers to EOS, and then we'll get into this. My guest today, it's Syed Jafri, CEO of EOS Cafe, the block producer. You produce on EOS, Wax, Talos, Bose. I have Links chain listed here too. I don't even know if that's still a chain. Obviously, the maker of Blocks.io, also DSP portal on Blocks.io, the Block Explorer, DSP on the DApp network, and most importantly for this conversation today, the winner of the $200,000 Block.one EOSIO Challenge bounty. And my other guest is no slouch either. It's Tal Muskal, the CTO of Liquid Apps, makers of the DApp network, over 20 years experience as a software developer and entrepreneur, open source OG. Tal, why don't you introduce yourself first? Let everyone know what your background is, what your role is within EOSIO, and we'll just start there.
Sure. I'm Tal Muskal. I'm the CTO of Liquid Apps. I entered the world of blockchain through my friends at Bancor. And I've been a very active developer in the EOSIO community, especially around developer tools, development tools, and all kinds of useful services as part of the DApp network. What else?
I think you're selling yourself short. I mentioned it in the intro. You're an open source OG, man. You were part. We've had these talks before. You were part of the open source movement before it was cool, before blockchain, from like the early 2000s and on. All right, so Syed, why don't you introduce yourself? Let everyone know what your background is. What attracted you to EOSIO?
Yeah, so Syed here. I've been in this space for 4 years now almost. I was initially attracted to Ethereum, especially especially the NFT space. I was quite interested in how CryptoKitties were working, how they were creating these non-fungible tokens, and then they moved on to actually creating a whole standard for that. I was working on a few smaller projects in Ethereum, but nothing that really went big. The real problem was obviously the fees, the performance, and while developing on Ethereum, I actually heard about EOS, and I moved into looking into EOS. I was looking into how it was getting these crazy performance numbers. And in early 2018, I started developing on EOS. And since then, we've run validator nodes for dozens of EOSIO chains, created the most popular Block Explorer, Blocks.io, and yeah, as that mentioned, and now also completed the EOSIO Smart Contract Challenge that went out in February this year.
Yeah, so I guess I'll take the opportunity to introduce that. So back on February 3rd, earlier this year, Block.one announced an interoperability challenge. They called it the EOSIO Challenge. They put out a $200,000 bounty for, it was a year-long contest. So it was meant to take a year for someone to build this. And this guy here, Syed, within 3 weeks, was able to run all of Ethereum within a single EOSIO smart contract. So as part of the challenge, it says participants must create an EOSIO smart contract which can store and invoke EVM, or Ethereum Virtual Machine, or Solidity smart contracts in a virtual Ethereum-like environment. The challenge enables developers in the EOSIO, Ethereum, and wider blockchain communities to use their preferred development platforms while leveraging the benefits of EOSIO. For example, EOSIO can process smart contracts faster, reducing the impact of a significant roadblock for developers. So that was like the TLDR on the challenge. I'm sure it went much deeper than that. But what was your response when you first saw the challenge? Did you know immediately that you were going to go after it, or did it take you a day or two of pondering?
Yeah, so I mean, it's a concept that I've thought about before. One of my good friends, actually, we were introduced to EOS at nearly the same time. Mason, he had actually been quite almost like a year or two ago. He was pondering about this idea, but it never went anywhere because it's quite a complex project of how to run Solidity code inside EOS. And to be honest, I'm not even sure if it would be really feasible a year or two ago when EOS came out. But for those who might not know, first of all, I'd like to start off with what a virtual machine is itself, right? A virtual machine is almost like a sandbox where you can run, most of the time, arbitrary code, any code. In the context of blockchains, virtual machine is where the code that developers create runs. So any code that you write on EOSIO, when the validators are running it, they run your code inside a virtual machine. And this virtual machine will take the results and give it back to the user or the developer, and also store any changes in the state that happen. But one of the issues is that virtual machines on every single blockchain are pretty siloed. I mean, different blockchains have their own languages that compile down into code that only their virtual machine can run. So in EOS, that's C++ code that compiles down to WASM, and the WASM is WASM stands for WebAssembly. So that WebAssembly code essentially runs inside the virtual machine. On Ethereum, it's Solidity or Yule, and now they're moving towards WASM as well. But these two virtual machines are not compatible. Think of it like Windows and Mac OS. So the same idea applies. If you want to run a Windows game on your Mac, what do? You download something like VMware or Wine or something, which runs that Windows code inside a virtual machine. So this challenge was essentially creating something like VMware or Wine for blockchain, where you're running Solidity or any Ethereum code in EOSIO. So that's where it involves the interoperability and using of programs that are written in different languages inside EOSIO.
As Syed explained, if I already had a contract that I wrote for Ethereum completely working, that I could plug it into this EVM and run it without any code modifications on EOSIO.
Right.
But there's, I see some limitations to this. I think the biggest one is that, like, not being able to bring like the liquidity with you, for example. But before we get into like some of the limitations with the solution, let's get into what is now possible because of the solution. Like with the solution, besides being able to migrate a contract, which is huge, without any code modifications, what else? What other doors does this open up?
I think, as you said, one of the biggest issues is obviously liquidity, but it doesn't necessarily need to. I think the challenge itself has nothing to do with liquidity. Obviously, it's more about opening up the technical limitations and easier interoperability. But with that comes actually an easier ability to move liquidity between chains, especially if you're working with the largest smart contract chains, which are EOSIO and Ethereum. So if you want to bring the liquidity over, it might end up being easier for you as well, because you're running the same code on both chains, and now you simply add in a bridge between the two codes that you're running. Instead of having to code up a whole new C++ smart contract and then trying to connect that C++ smart contract to your Ethereum contract. And that would also increase the attack scope. And the security is just much harder when you're coding in multiple different languages trying to meet the same targets. And a lot of teams probably don't even have the resources to be maintaining multiple different versions of their contract. So this would simplify all of that. In my opinion, it would make it much easier to move liquidity between chains, namely Ethereum and EOS.
I have a couple of technical questions that are related to like a part of the interoperability is the environment and the ecosystem that you're running, right? It's not just the language, it's kind of the external interface to other contracts and to other things. So I imagine, like broadly speaking, I imagine that if you want to port your application or your DApp to Ethereum, and you want to bring, and you don't want to touch it, and you want to bring it as is, you probably want to bring your ERC20 token as is. Otherwise, you kind of need to kind of breach that kind of notification or interception of the transfers and things like that.
Right. I mean, one of the things that I think is not covered by the challenge yet, but it is something I talked about in my submission, is we need to add in a way to move. So there's ways, obviously, to move transfers into the EVM. I mean, you can transfer, let's say, is deployed on EOS. You can transfer EOS in, and then that EOS is movable inside the Ethereum virtual machine on EOS, so eosio.evm. And all the Ethereum contracts can interact with that EOS as they would any balance, such as Ethereum. But the one thing that wasn't in the technical specification that could be easily added as required would be taking that balance out. And there's different ways you can do that. It could be an EOS action, or it could actually just be, it could be like an Ethereum OPCode, where people build that into their Ethereum contract to withdraw to an EOS address. And that would all be done quite seamlessly through the EVM contract. But it is something that I'm more interested in seeing, how it's required, how people want to use it. But it's definitely possible to withdraw the tokens out to another EOS address. But the formal specification of the challenge was essentially to emulate nearly perfectly the entire Ethereum virtual machine and the way Ethereum processes transactions and processes code. And obviously transferring out to an EOS address isn't currently part of it. So I'm excited to see what people wish to see and how they wish to use it. And I think the EVM will evolve according to those needs.
Cool. And what about the integration between EVM-based contracts, like internally inside the EVM? Is it like the same kind of integration that you do with a group of contracts in Ethereum, or
right? So the EVM is essentially an identical copy of the way Ethereum works. The only main technical difference I can think of is we use a key value store instead of using a Patricia Merkle tree, because recomputing that tree inside of an already virtual machine like EOS and then storing that whole Patricia Merkle tree. Although I think some Patricia Merkle trees are already stored as key value pairs, but it would still slow it down. So we directly store it as key value. But other than that, everything works the same. I mean, we're passing all the Ethereum tests that are possible, that are not like using tons and tons of memory, which wouldn't be possible, obviously. But other than that, we're passing the thousands of Ethereum tests that they use for their protocol consensus. So essentially, anything that you can do in an Ethereum contract, you can do in eosio.evm. There's no real limitations. With one notable exception would probably be like some of the heavier zero knowledge proofs, which still need more optimization. But that's simply, it's not a matter of that it won't run. It's just that it takes too much time to run for the really complex zero knowledge proof circuits at this point.
Cool. And what about things like failed transactions?
Right.
Ethereum. Yeah.
That was actually the hardest, I would say, the hardest thing to do inside EOS, because for those who might not know, the way EOS works is if you have any error inside EOS, it will fail. It will completely fail. But Ethereum doesn't work like that. Ethereum has different stages in a way of the contract. So if the transaction fails immediately in Ethereum, it will get discarded. But if it doesn't fail immediately, the first thing it does is actually charge you for gas. And most importantly, it doesn't charge you for gas immediately. It increases the nonce of your account. Even if the whole transaction fails, it will increase the nonce and then eventually also charge you the gas, even if the transaction fails. And the other challenging part is in EOSIO, there's no try catch. You can't just wrap the whole thing in an error handler. You can't just catch all the errors.
So you're disallowed from using errors whatsoever.
Exactly. So actually, in our code, past the after we increment the nonce, we're not allowed to use EOSIO check, which is the assert mechanism. We simply can't use that. So we had to we had to adopt more of the Google way of writing C++, where they don't. Google doesn't actually use any try catches in most of their code. The way they do it is by returning like status codes or errors from every function if anything goes wrong, and then handle those. So that's what we do. We don't. There's no way to throw an error inside the contract. And
it's the same in kernel code. Kernel code also doesn't have try-catch blocks for almost the same reasons.
What do you mean by internal code, sorry?
Kernel, like...
kernel code, sorry. I heard internal code.
So, yeah. Also don't have try-catch.
Yeah.
What is this try-catch, and what implications does it have to not have it?
Right. So try-catch is a way, essentially, you wrap your code with any code. It's in multiple different languages. It tries the code that you put in the try part of it, and then if there's an error, then it moves on to the catch part of it. It's a way to catch errors.
So it's like an if-else type thing, and just...
Yes, in a way, like if you do if-else, like if the if part of the code would be if there's no error, keep executing. But if there's ever an error, then it moves to the else part. So I mean that would be really useful, obviously, for our EVM2 if it was available. But WASM itself doesn't really have stable error handling at the moment. It's in more like a proposal state and implementation state. but that is definitely it was definitely a big challenge, because if you want to emulate the way Ethereum works, you have to do that, because otherwise your nonce wouldn't increment properly when putting in transactions, and it wouldn't work the way that Ethereum developers are used to. And I actually think some of the solutions, from what I looked, some of the other submissions, were not able to do that. And also we're missing rollbacks. That was another big challenge in doing this.
Before you go into rollbacks, so let me see if I understand you correctly. So if you're running a transaction in the EVM, unlike EOS transaction, it would actually be written to the chain, even if it's like a failed EVM transaction, just so you can progress the loans.
Right. It would always be written, at least the fact that you submitted the transaction. And if it fails, then just the nonce would be increased for your account. And I think that would be it. If the outer level transaction fails, then only the nonce would be increased for the account, but it would still be saved, unlike EOS is.
Right, and what complicates the entire challenge is that when you write an actual transaction to the chain, all the changes in the state comes with it. So you can't rely on the rollback, on the inherent rollback that the block producer gives you. You need to roll back all the changes yourself. You need to manage all the changes yourself and then roll them back efficiently.
So I mean, to go a little deeper into that, the way EOS works is, let's say you put a transaction in the middle of the transaction, it increases the number of apples you have by 1, right? If there's an error later in the code, the whole thing gets reverted back. You don't have one new apple anymore. It goes back to how the chain looked like at the start of your transaction.
And as a developer, you don't need to explicitly say anything. You don't need to handle that edge case.
Right, and it's quite nice. It works automatically on EOS, and it's the same thing with if you run a transaction, which once again I'm going to continue with this fruit example, but you're incrementing the number of apples somebody owns. And then in a child action, you're incremented how many pairs they own. If there's an error in incrementing pairs, everything gets rolled back automatically. Your +1 apples also gets rolled back. But in Ethereum, it's not necessarily like that. It's very possible for you to increment your number of apples, but if your pair transaction fails, that's all that fails. The apples still get incremented. So we had to essentially code a completely new rollback mechanism to handle this. We couldn't rely on the native EOS rollbacks, and that rollback system can handle child rollbacks. So the actions or parts of a transaction can roll back, while the whole transaction doesn't, which is not possible with EOS right now, but it is possible in eosio.evm. So those were the two biggest challenges, I would say, were especially the rollbacks and handling transaction failures.
So essentially, you had to develop your own transactional memory mechanism, like
right.
nested. And another thing that's what about re-entrancy? Like it works the same way in terms of invoking.
Right. Yes, re-entrancy works the same way.
Okay.
I mean, once again, I feel like it's good to explain these concepts. So re-entrancy, for developers who might be new to EOS, coming from Ethereum, you would be familiar with re-entrancy, which is when your contract calls another contract, that executes immediately. So your contract code stops running, and now that other contract starts running immediately. But that other contract could, in theory, call your contract back with another action or another transaction, and that would be a re-entrancy, because now they're re-entering your code. And this has actually caused a lot of hacks, a lot of security issues in Ethereum, and now they explicitly try to guard it with recommended coding tips and ways to code. But EOS is different. The way EOS works is if you call another contract, it does not execute immediately. It executes after your current action is done executing. So EOS by itself does not allow re-entrancy as a smart design choice, in my opinion. But since we're emulating the EVM completely here, the EVM does allow re-entrancy just the same way as Ethereum would.
Cool. I agree with that re-entrancy saves, like avoiding re-entrancy saves a lot of edge cases and security issues, but the alternative of having dispatching an action only after your function finished is the thing that actually prohibits you from returning a value from that action. And that's a kind of a limiting design choice in terms of how you can encapsulate logic in several smart contracts.
Right. I mean, but EOS has EOS obviously has workarounds to that. I mean, you can't return a value exactly, as you said, which you can nicely enough in Ethereum, but the way in EOS usually works is like that action would save to a table or a state, and so when you call a contract, right after you call it, then you call one of your own actions, and then it would execute an order, obviously. So that other contract would execute, and then your other action would execute, which checks how the state has changed. So it's a more of a roundabout way of, in a way, returning values. And I would agree that it makes it a little harder to do that composability, but I think it's quite worth the security. I mean, we've seen probably at this time over $10 million or more lost to re-entrancy bugs on Ethereum.
Right.
So I think it's a price worth paying.
You know what I would do? I would probably add another intrinsic or another building block to the language, just enforcing some functions to not be able to re-enter, just fail if they re-enter. Just have the flexibility of allowing other functions to call you, and just kind of like protected and private in terms of function call accessibility, but for that aspect specifically, and even have it protected by default. Probably what I would do, because composability, having very easy composability is crucial, and I think it's too opinionated to take it completely out of the language. That's if we discussed like the design choices that we would do differently. That's definitely something that I would do different. You mentioned earlier that you can dispatch a function, and then based on the result of that function, if it fails, do different things. That's also part of composability, like error handling. That's also that queue-based, async dispatching is a bit limiting.
Right.
But I agree, there are ways around it. But if you're trying to attract people from existing communities and existing platforms. I don't think they like there are workarounds for everything. I think that's why I'm so excited about what you did with the EVM. It gives you everything you're used to as the Ethereum developer, the good and the bad. Because the bad, the best Ethereum developers already know how to handle like the security blockers.
Yeah, and just to outline how identical it is. I mean, we easily created, and we actually included as part of the solution a mock RPC, a server which mocks an Ethereum RPC server by just using the EOSIO.evm contract. So with this RPC server, you can use it as a server URL for any Ethereum service. I mean, we published a video showing both MetaMask and Remix, which you create contracts in, working perfectly with EOSIO.evm. You just put in your mock RPC URL, and then it's in the backend. It's using that mock RPC, and it's using the EOSIO.evm contract on EOS or EOSIO instead of using any Ethereum nodes. And it works natively like that. And I don't think we've mentioned this before, but you're able to run at nearly 1,000 transactions per second using EOSIO.evm with Ethereum code. And as you can already imagine, this is orders of magnitude faster than Ethereum. And
have you ported the CryptoKitties yet?
Pardon?
Have you ported the CryptoKitties yet?
No, we have not ported the CryptoKitties.
I think they ported themselves. Didn't they launch their own blockchain or something?
They did. Dapper Labs, which is the team behind CryptoKitties, launched their own blockchain, Flow, I believe.
What contract did you personally use to test it? Like when you worked on it?
So, I mean, I started off with ERC20, and then we did tests on ERC 721s. Those were the two main contracts, the ERC20 and the 721s. We haven't, I mean, they were simply, I mean, we did use a lot of the contract tests, but that was one of the requirements of the competition itself was running ERC20 and ERC 721 perfectly, and obviously the thousands of tests that live under the Ethereum test repository, which tests nearly all functions of how a transaction is supposed to work, and it also tests all the state, like the before state and the after state.
Let's say I now take that EVM.
Right.
I take all the blocks that were ever written in the real Ethereum network.
Right.
And I use an oracle to pass them into that EVM.
Right.
And I keep thinking it. Like eventually I'll have a contract in Ethereum that keeps on updating to the entire state of Ethereum.
Right.
So essentially, just by doing that, I could, by relaying the blocks like with something like liquid oracles, I could make everything in Ethereum accessible to EOS.
Right. I mean, there's some problems there. Like copying blocks exactly won't match the eventual state of the EVM because there's no real concept of Coinbase.
Not the exchange, everyone.
Not the exchange. The Coinbase address is the address which mines the block. And in the EVM, there is no block mining, right? So Coinbase payouts are actually something that are just built into nodes. It's not built into. There's no special transaction that goes out initially to credit the Coinbase balance. So
yeah, you could emulate it quite easily.
Yeah, I mean, you could definitely add it. I'm saying that as the EVM as it is right now would not account for the Coinbase transactions that you would have to do to match the state perfectly with Ethereum. But other than that, everything else should match.
Cool.
I can tell Tal's wheels are already spinning like halfway through this conversation.
No, it's interesting that you could intercept things in your EOS smart contracts just by emulating everything with the EVM, not just for migration purposes, just for saying I want to be able to read things from Ethereum, and the way I do it is I just play the entire Ethereum chain on that contract and can access and listen to events that are happening there, and assuming I only relay irreversible blocks.
Right. There are also a few minute changes, like the block number opcode would obviously would return the EOS block number, and not the Ethereum block number, obviously. This is all in the technical specification that Block.one put out. So their technical specification has all the changes that are required from the Ethereum yellow paper, but everything else matches the Ethereum yellow paper. It has all the pre-compiles too, even the zero knowledge ones working. So.
And do you track like gas?
Yes, so we do have gas tracking, and you also have the ability to turn it off as was required. So it will fail the. Yeah, sorry.
So it includes gas limiting as well, like quota for gas.
Yes, it does. So the in the specification itself, you had to track the gas and fail the transaction if it goes over the gas limit, but not charge the sender. But we do have a flag if you want to turn on charging the sender. But it by default it's turned to false as by the specification.
And you do charge gas for failed transactions as well, like up to the point of the rollback.
Yes, yeah. If you turn on that flag, yes.
Sure. Cool.
But by default, the flag is turned off and no gas is charged.
Cool. Interesting. Very cool. I have a very, very technical question about the nonce, actually. Like I know that in Ethereum, if let's say you skip a nonce, let's say there are hundreds of you skip the nonce by 100, and it's in the transaction pool of all the miners.
You can't skip nonce of what, like an account nonce?
Right. Yeah.
You can't skip the nonce. The nonce is not user specified.
So technically, in a transaction, you could, as far as I know, you could skip a nonce, and it wouldn't get written into the chain, but it still exists in the transaction pool. Up to, like, let's say I skip 10 transactions in the nonce, then I start shooting the first, the second, the third, like fill the gaps. Eventually, the transaction that I send, the old one with 10 transactions, it gets removed from the transaction pool. But you're right, it's kind of maybe out of scope because it's in the minor transaction pool and not on chain.
I haven't seen that. I think the way you would do that is by putting a crazy low gas on that high nonce, and then having the other transactions come in with beforehand with higher gas. But if you have normal gas and you put in a nonce that's 10 nonces ahead, the node will just fail it and remove it from the transaction.
Oh, no, it gets stuck. I know that's for sure from Banco. It gets stuck in the transaction pool. If the gas fee is too low, you can later resubmit the transaction and only increase the gas. It's an interesting topic because it's one of the problems that the nonce mechanism is very problematic for app developers in Ethereum. Actually, it's a very problematic thing to track, to understand like what's the right nonce to submit your next transaction. Because you sign with the nonce, so you need to know the nonce of this.
Right.
One of the biggest advantages for Ethereum is their development community is just insanely mature and large. What would need to happen for EOSIO to catch up?
Yeah, so I think Ethereum has seen this Cambrian explosion, I would say, in the last 2 years mainly. You can include 2017 too, but a lot of it was actually just people fundraising money to do development in the years after. But the 2017 to 2020 has been great for Ethereum. But the real thing that I think led to this huge growth in Ethereum as well was really how much their developer tools have matured. A lot of the ways of learning how to code in Ethereum, a lot of the security bugs, a lot of the coding practices, they're all well documented now, public. There's some really good tools for development. Things like Ganache and Truffle have come a long way. The Open Zeppelin repositories with sample contracts is just phenomenal right now. I mean, when I was writing up an ERC20 or ERC 721 contract for this challenge for testing, I think I wrote the ERC20 contract in like 5 lines because you just import from Open Zeppelin and then you create the token. Things like that have really made it much easier to start off on Ethereum. I think that really helps promote the developer ecosystem there. As for EOS, I think the protocol is still quite evolving quite fast. One of the issues that we saw in the first year was the core protocol was moving so damn fast that documenting it and documenting all the changes was hard. We would release like a tutorial or something, or anyone would release a developer tutorial, and within a month or two, there were so many new changes and so many new features that tutorial was not as relevant. With Ethereum, the coding has, for the most part, really solidified. They have one major change, if even every year, with a hard fork that developers have to account for. With EOS, I think we're now starting to see the advent of these developer tools, and I think as these developer tools mature more and they're more robust, we will see an increase in development on EOS as well. And EOS development also all depends on the user experience. I mean, the user experience is great in the sense that a lot of times there's no transaction fees, it's fast, it's instant, but there are obviously limitations as well with resource management. And that is, I think, over the last 6 months to 6 to 12 months, it has really been abstracted away, and it's being increasingly abstracted away more and more. I think with great wallets like Anchor now, Anchor by the Greymass team, they're covering CPU for all users. Blocks.io, if you use it, we cover. If you use it with Scatter or your own ledger directly with Blocks, we cover 25 transactions every single day for every user. And there's not many users I know who make more than 25 transactions per day. So it's really, I think the user experience is coming along as well. We've moved a long way from the point where people thought they couldn't use the network for that month last year. Yeah, I think it's getting better every day. There's still a lot of work to do, but excited for how it's going to grow.
I think another interesting thing that's now possible is to take what Syed did and take the logic out of Ethereum and keep the liquidity on Ethereum and just have all the smart contract logic still sit on something that has cheap resources like Ethereum, and something that can transact thousands of transactions, including oracles and all the capabilities that we're familiar with, and just react to things that are happening in Ethereum on that level, and keep the tokens and keep the liquidity and keep everything on the exchanges, and have users use their existing tools and just offload the execution to Ethereum. I think that's an exciting opportunity that's now possible.
Syed, did Block.one give an indication of what they plan to do with your solution?
No, I have not heard about anything.
Besides the challenge and the reward, what got you excited and why you wanted to see it happening? I know that you're probably like me. You don't write a line of code without like being kind of excited about it and what it enables. So what got you excited about it?
I think personally the biggest thing for me personally was the fact that it's quite a learning opportunity for virtual machines. I think, and that's obviously a personal thing, but I think I understand after the challenge both EOS more, but Ethereum very well from the inner workings of Ethereum, the way it works. And I had previous experience in coding and Solidity, obviously, but the inner workings are very different. And I think it's really exciting as for me personally as an onboarding tool. I think for any developer, any company, there's lots of companies that have Ethereum code written, etc. But they don't want to use Ethereum, or they can't because of the speed limitation or the cost limitation. I mean, right now, some simple actions end up taking like $1 for every transaction on Ethereum right now because of how crazy the gas fees are. So as an onboarding tool, I already talked about the liquidity. You can create cross-chain liquidity platforms much easier if you're running the exact same code on all the different chains and simply acting as a bridge. I think there's I'm not clear right now on how it might be used for some sort of proof-based IBC between EOS and Ethereum, but it is possible because you can run the transactions. So you could add proof verification on top of it. Aside,
you mean proof, not proof for the proof of work part?
No, more of validating blocks essentially from the Ethereum chain. Validating the
you could theoretically validate the longest chain, proof of work chain as well inside the contract, but that would take 2 gigabytes of memory, I think, to hold like the tag, right? To hold the graph, the random graph.
Yeah. like the actual resource consumption on that would be quite high.
Right, right. But with EOSVM too, who knows?
Yeah.
Quite efficient.
Yeah, and I think I'm also quite excited for if we see more improvements and especially big number calculations on EOSVM2 in the future. It would make doing zero knowledge proofs easier. I mean, even right now, so one of the hardest precompiles on Ethereum is the addition and multiplication on the BN curves, the curves that they use for the zero knowledge proofs, and those are the ones that take the most time even on EOS to run for transactions. But if we were able to do some sort of like 5x, 10x reduction in the time of running these arithmetics, you could run way more complex zero knowledge proof circuits. And you could even adopt a lot of the code that's currently open source in the Ethereum community to construct these zero knowledge proofs and also run them. There's already different frameworks on Ethereum that I know of that you can create the Solidity code, and it compiles down to bytecode for creating zero knowledge proof circuits. So things like that can be leveraged too.
Actually, you could also propose a protocol upgrade just to expose the primitives that you need for that, and then even have it run more efficiently.
Right. I believe one of the projects POs was trying to do that. They tried to. I think they proposed Intrinsics.
Right.
But intrinsics take a while. I mean, because they have to go through a long review process. I mean, because any new intrinsic requires a whole new upgrade to every single node in the chain, essentially like a Ethereum hard fork.
But there's now the protocol upgrade, the feature protocol upgrade process that you could create, which kind of makes it easier.
Right, but I think for this you would need a hard fork still. If you were to introduce a new intrinsic for zero knowledge proof or multiplication and stuff, I think all the nodes would have to upgrade.
I think one of the protocol upgrades was protocol. Maybe I'm mistaken, but it was the ability to detect protocol upgrade.
Right.
So that you could kind of roll out something and only use it when everyone upgrade.
Right. I actually didn't understand that completely as to whether we need, whether it completely removes the need for hard forks, or there are still some changes that would still require hard forks. Because it would be great if the protocol upgrades can just cover situations like that, and then you don't even need things like hard forks to upgrade the chain.
Yeah, I think it's supposed to, but it probably doesn't cover all the cases. But I think for new functions, for completely new functions, it should allow you to do those exactly those kind of things. Just ignore, especially if you have a fallback function that implements it without the intrinsic, then you can just condition the protocol exists. If it doesn't, just run your emulated version.
Right. With EOSIO EVM, there's obvious speed and scalability and throughput enhancements for an Ethereum project that wants to port their contract to EOSIO. Throughout this process, you mentioned how you got a deeper understanding of Ethereum from it. Is there anything from EOSIO EVM that actually could be an improvement to EOSIO rather than the other way around?
Yeah. So I mean, obviously, some of the biggest things would first of all be error catching. It would be really nice if you could catch errors. If you could catch errors in the actions you call, if you could get, I think they're working on something like this actually, of returning values from actions you call. That would be really great. Debugging. I mean, one of the great things of developing in Ethereum is the debugging. You can debug at every single execution in the virtual machine. And I believe this is in work as well for EOS, where you could debug every line. So if your contract fails while you're running it in the debugger, you would know exactly which line of code failed, and you could perhaps even go back or forward in the debugger, which would be great. Other than that, I don't think there's much else. I mean, they're both pretty like complete platforms.
All right, so I'll rephrase this question for you, Tal. If you could re-architect EOSIO from scratch today and make a minor, major change, whatever you want, what would you change about EOSIO if you could rebuild it today?
I would make it a bit more like, even more like an operating system, in the sense that I would have system contracts serve as kind of a common library, and the kernel itself is something that could be upgradable. I would probably decouple system contracts and the very basic things that the node exposes to the contract. Kind of like there's a libc in Linux, and there's the kernel, which do different things, and every contract can enter. In Linux, every process can be in kernel mode or in user mode. So I would apply the same kind of design pattern to EOS as well. Right now, you're either in a system contract context or your own context, and it doesn't give you that much flexibility to upgrade the building blocks. It's either like a protocol fork or a system upgrade that would allow you like very good reusability without changing the node itself. You could upgrade the system contract using a multisig, and then change something in the common layer that all the dApps use without having all the DPs to upgrade. Get what I'm saying?
I'll defer that question back to Syed. If you have a comment on that, and then I guess the same question for you.
I think from more of an application point, I think there's a lot of improvements that I would make if things were changed. Mainly with the resource model. I think well, one of the hardest part, and I know a little bit about why the design choice was made, is the unpredictability in billing of CPU, right? Like on Ethereum, for example, the same transaction will always take the same amount of time, time being gas. But on EOS, depending on how fast the validator's machine is or how they bill, it takes different amounts of time. So that makes it hard to estimate resources ahead of time. Still, this is not implemented yet, but it could be. Actually, I ran some tests myself where if you take out some parts of the code, you can estimate ahead of time how much. You can essentially mock a transaction. So you put in the transaction, it doesn't apply, but you know how much CPU, net, and these two are approximate, but you would know exactly how much RAM it would take for that if that transaction was applied. So wallets can use things like that to ahead of time estimate how much resources the user needs, and then just show warnings or just apply it directly. You know, I think this is one of the things that wallets and EOS have really dropped the ball on. Ethereum, they just adapted to the fact that you have to pay costs. And on EOS, when it got congested, it was very easy still to just rent for like 1 cent or even cheaper from Rex. But I think wallets didn't evolve fast enough to simply integrate that process in. And I think that degraded user experience to a good degree, where wallet developers simply, as they were unfamiliar with it, dropped the ball, and they could have quickly adopted a transaction fee model, or even cheaply just pay fees. I mean, I think last month on Blocks.io, we paid maybe 2 EOS for the whole month in covering transaction fees, and we've covered thousands of users over the last month just with 2 EOS. So I don't really see why some of these wallets, which might even be charging, they show ads, they promote other dApps, which we don't do on Blocks. We have virtually 0 advertisements there. I think most of these wallets can do that, and Greymass and their Anchor wallet does it. I know other wallets, Wombat does it. So I think, as I would say to users, if your wallet is not covering transactions or making it easy for you, move away. Use a better wallet. I think if you're still using Scatter, you should be using Anchor. I think development on Scatter is not active anymore. Anchor is a great wallet. Yeah, I think that's all I have to say.
I think you're right. So if I interpreted your answer correctly, if a wallet had this functionality during the IDOS stuff, let's say I'm sending 1 EOS to you,
right?
And I would get an error saying you don't have enough CPU, this transaction failed. If I don't really know what I'm doing, I'm just like, all right, what do I do next? Whereas if the wallet had better UX UI, I'd be like, all right, we can't send this 1 EOS the default way, but if you're willing to pay 0.0001 EOS, we'll send it through for you. Will you accept this fee? Yes.
Right. Or even if in Ethereum, they don't even ask you a prompt. It's just like, if you don't have enough CPU on EOS, simply just show right there as one of the items to show transaction fee 0.001 cent. That's your transaction fee for this transaction. Very easy. It's much easier. I think as a wallet, it is your responsibility to be making it as easy as possible for your user. Instead of it's funny because I saw many wallet developers just be like, oh, the chain doesn't work. I mean, that's why your transaction's failing, right? The chain works. There's no possible way for a chain to be number 1 in blocktivity in chain activity, and for a developer to say it doesn't work. How were all the IDOS miners putting in transactions? They were clearly using the mechanism of Rex and paying. They were willing to pay money to put their transaction into blocks, the same way gas fees work. So I think that was one of the big shifts in EOS history, where the concept of transaction fees in a way was reintroduced. And I think the hybrid model is good, right? Like, if you have lots of EOS, it will most likely cover free CPU for you. You don't need to get more transactions. You don't need to pay a gas fee in a way. If you don't have a lot of EOS, then yes, you're going to have to pay EOS as a transaction fee. And that transaction fee is still an order of magnitude cheaper than the next biggest smart contract chain, which is Ethereum. So I think it is the responsibility of wallets, and I'm glad to see that other wallet developers, aside from Blocks.io, have stepped up. And it's more important that core wallets do this, right, than something like Blocks.io, since we're a web wallet. But it's more important that core wallets like Anchor and Wombat and some of the other, perhaps Token Pocket, have done it, because that is what users use for different applications as well, aside from Blocks.io.
I agree with you, and to add to that, I think one of the problems that this kind of resource model introduced is the fact that each block producer can can fit different capacity in its round, it made it very volatile, the CPU consumption. So you could dispatch a transaction to the network thinking it passed, thinking it got through, but it actually didn't because of that verification process that went through, but it didn't really propagate to the BP node. If we would take the same resource model, but instead of measuring CPU with time, but with opcodes, it would make it much more deterministic and much more easier to deal with, even as a DApp developer.
Mm-hmm.
Because right now, the fact that it's volatile and undeterministic is a problem. Not just the fact that you have three variables to control.
Right. It's just such a different, it's the different paradigm, right? Like opcodes are great for determinism, but it's really limiting. I mean, like you can't run, like one of the biggest reasons that you can run Ethereum on EOS, but you can't run EOS on Ethereum is the fact that it's opcode based. It's not complete like C++ that just works. It's this compilation down into this much simpler language. I think, I mean, maybe I'm just thinking. I'm thinking on the spot right now. Maybe it's possible that you could compile entire C++ code into opcodes. But I think it would be very hard to do that for any arbitrary code. I think you would have to have a very small subset of C++ that is compiled down in the same way that you have Solidity, which is a new language itself that they need to compile down into opcodes.
But let's say we would go over all the assembly commands in WASM.
Right.
And give each of them like a cost. And just do that. Start with even arbitrary costs for every assembly and let the block producers tweak that. It won't really limit anything. And
that would be interesting, yeah. If you actually that's actually a really interesting idea. If you assign a cost to every single assembly operation, and then did gas metering on assembly code like that.
Yeah,
that's definitely very exciting.
And you could start arbitrary numbers and just tweak it over time.
Right.
And I got lost a little bit ago, but hopefully a lot of people understand all this. One thing, I guess, for you guys mentioned opcode. What exactly is opcode?
Opcode stands for like an operation code.
Okay.
They're just essentially like instructions of
the virtual processor.
Yes. So in Ethereum, essentially Solidity is the language you write in, but it gets compiled down to opcodes. So opcodes would be things like copy data, or like copying data from one memory address to another, things like that. Okay. It's very, very low level.
I think we nerded out for a while here. Guess we could finish this off with I guess talking about some of the stuff you're both working on. Syed, I know you got your hands on a lot of projects, a lot of different blockchains. Is there anything that you're working on outside of Blocks.io and outside of the EOSIO EVM that you want to kind of plug or talk about?
Yeah, so we are working on. I mean, we're always constantly still working on Blocks.io. I mean, one of the latest additions. We've been working a bit on. We've been working actually a lot on NFTs in the space. We've also launched an NFT marketplace on Wax. So we're quite excited about the NFT growing in the EOSIO ecosystem. I think NFTs have a lot of use cases, primarily in game. I'm more interested in the gaming aspects of it as a big gamer myself.
Mm-hmm. Which is what you said got you into to begin with, or the development of it at least.
Yes,
CryptoKitties.
It actually got me into Bitcoin too. I mean, interestingly enough, the first Bitcoin I ever owned was like $10 a Bitcoin that someone tipped to me after we played a game back in 2014. So I think gaming has been great, and it's one of those things that really makes sense, right? Because virtual currency is everywhere in gaming. So it's a very small jump to go from virtual currencies to blockchain. From a mindset perspective.
I also think NFTs, I'm also really excited about NFTs because it's one of the first real use case that anyone can understand why it's important for it to be immortal, or at least, there after, regardless of the entity who created it. Like in terms of, if you have a collection of something, you want it to last for a lifetime. If you collected cards or stamps, you want it to not be dependent on really on anyone to for it to survive. Otherwise, you don't really know what's the value. So NFTs is a really good example of why you need something to stay somewhere forever.
Most people understand collectibles in general. You understand the kid that collected baseball cards when he's little, he still wants to have those baseball cards when he's old and potentially be able to liquidate them if he needs to.
And same thing goes to right management in music. Like DRM and ownership of digital, right management on media. We used to collect, records or CDs, but these days you wanna still collect music and have your collection, but not really be dependent on something like iTunes forever.
Right.
Who knows what will happen 30 years from now?
Yeah, I'm excited for the NFT licenses, something kind of like what Ultra is doing, where you can kind of like transfer a gaming license, and there could even be like a fee from the resales that go back to the original publisher. That's something I've seen on Wax with their NFT marketplaces. Like Tops, I don't know the exact percentage. You might know they get like 8% of every resale in perpetuity that happens on any marketplace. That's huge for collectible creators, game developers, to have that long tail of a revenue stream that just wasn't possible before. So it'll be cool to see those business models kind of get upended and, like, use the term that's overused, disrupted.
I also want to start seeing multi-game economies, like NFTs that have value and usage in more than one game. I think that's something that's very interesting. A new kind of modding for games. That's something. Ever since the launch of the mainnet, I've been waiting for someone to kind of utilize that new possibility.
Yeah, I think especially with because you could essentially put, I mean, maybe not all of it on chain, but like links to like 3D models right inside the NFT. So it'd be really cool if you could use, in, let's say, 2 different open source, like open world games, you could use your 3D models there, which are linked right to the NFT. And then you're essentially, your character becomes an NFT, right? Which is quite interesting.
You can even say that there are NFTs that you model yourself, or you give each game its own booster for the NFT. Like a sword can mean something in one game and can mean something else in terms of abilities in another game. And it's a kind of a marketing tool to target the people who have the NFTs, like the whales who bought the most expensive NFTs. As a game developer, I can now say, I target those, I support those NFTs in my game, and that's a way to bring new audience. Right. So that's also exciting.
I want to see, I told some other people about this, but with the NFT marketplaces blowing up on Wax, and I know that they have the TOPS relationship, which is eventually going to lead to like professional sports leagues. On all of the like Madden video games and NHL and MLB games, they have this in-game, I guess, game within a game called Ultimate Team, where you collect cards for your favorite players, and they allow you to essentially combine cards to make them into a better, more rare card, which, since you're burning cards to create that card, you're making it even more scarce on the next tier down. So I think once we start seeing stuff like that, it's just that's what has me excited. And it's just because it's something familiar with to me, but I want to see some of that stuff.
Yeah, we actually have something called universal crafting contracts that does kind of that net built, which we haven't released yet. That's like a simple assets and goods, but you can have like recipes, and then
that's exactly what I was talking about. That's exactly it. I think I saw you mention that before. So I guess this all started with me asking Syed what he's working on that people might not know about. So I guess we could wrap this up. I might know the answer, but maybe I don't. Tal, what are you working at with Liquid Apps or outside of Liquid Apps that people might not know about that you want to share before we close out here?
I'm working on improving the existing services, having more capabilities and more use cases for the things we released, especially on the computation side, improving vCPU to get it to a place where you can run code that's not the conventional code, not blockchain code, and have it interact with contracts. I think that will also address a gap that we constantly hear about, not from blockchain developers, but from people who wanna enter the industry. Everybody wanna reuse existing things, and we're quite used to reusing 90%, of our system from open source code, and only focusing on the business logic of our app as much as we can. So we're trying to bring that more and more. I think that's what we've been working on since the beginning.
Everyone who made it this far, thank you so much for watching. If you didn't already do it, leave us a comment of what you thought about this episode. I know it got a lot more technical than we typically do, but I hope there's a lot of value to be gained. I know for the developers out there, they probably really, really enjoyed this. But we close out these shows in a very specific way. This is Everything EOS.
Go EOS!
Go EOS!